Hey guys, I'm Daniel, and the question we're going to be doing today is it takes 42 minutes for the concentration of a reactant in a first order reaction to drop from 0.45 molars to 0.32 molars at 25 degrees Celsius. How long will it take for the reaction to be 90% complete? Okay, so let me go ahead and write the equation for a first order reaction, which is ln of AT, which is just final concentration, is equal to negative KT plus the ln of A naught, of concentration of A naught, which is this initial concentration. Alright, so we're going to be doing two separate pretty much equations right here. Okay, we're going to be using the information inside from 0.45 to 0.32, and we're going to be using that time to find the rate constant and apply it to the second reaction, and that'll make a little bit more sense in a little bit. Alright, so let's first start off by labeling what our givens are. Okay, so our initial time given is 42 minutes. Okay, so T is equal to 42 minutes. Alright, A naught, concentration, is equal to 0.45 molars. So let's write that down. And final concentration, AT, is equal to 0.32 molars. Alright, so we're going to be using these values, plug it into this equation to find our rate constant. Alright, so let's go ahead and start getting to the math. So the ln of 0.32 molars, and I'm going to first already start off by moving this ln over here. Okay, so I'm going to be moving this over here to isolate our negative KT to get closer to isolating K. So and just in case you didn't know this, but it's a natural log property where it's ln of AT minus ln of A naught is the same thing as doing ln of AT over A naught. And you can see for yourself if you have doubts about it, or if you want to make sure for just in case you want to use it for on the exam. Alright, so you divide that by that is equal to negative K times 42 minutes. Alright, so let's go ahead and plug this into our equation, or to the calculator. So ln of 0.32 divided by 0.45 is equal to negative 0.341 is equal to negative K times 42 minutes. Alright, so let's go ahead and move this 42 minutes over to the other side of the equation to isolate K. So you divide that by that, and you get 42 minutes. So that divided by 42 is equal to negative 0.00812 is equal to negative K. And once you multiply this negative K by negative 1, you end up getting plus K is equal to plus 0.00812. And that's our K. Alright, so if you haven't already, go ahead and write this down if you want to. I'm going to be erasing so that I may proceed to the second part of this problem. Alright, so go ahead and write it now, and I'm going to be erasing. Alright, so the second part of this equation is to use this K value and plug it into the second reaction that we're going to be doing in order to find the time, alright, for the reaction to be 90% complete. Okay, so we don't know T, we're looking for T, so let me write down T equals question mark, and A naught, concentration of A naught is equal to 0.45 molars, and the concentration of our final product is going to be equal to 0.45 molars times 90, actually times 10 over 100, because after the time that proceeds, you're gonna have 10% remaining. Okay, because it's going to be 90% complete. That's going to mean you have 10% of your reactant left inside the product. All right. So once you do that math, I believe you end up getting 0.045, but let me double check that answer. All right. So times 10 over 100. Yeah, you get 0.045 molars. 0.045 molars. And let me go ahead and erase this. Alright. just to free up some space. So 0.45 molars, 0.045 molars actually. And let's put that K over here as well. Let's free up some space. So 0.00812. Actually, I forgot what the. Oh, actually, it's minutes to -1. I almost forgot the units for that, but let's go ahead and go on to our reaction. All right. So we're going to be plugging in these values again to find T this time. All right. So we have ln of 0.045 molars over 0.45 molars, and we're using the same algebraic property where ln of this divided by that is the same thing as subtracting them. All right, equals negative k. Actually, we have k, so let me plug in k. So negative 0.00812 times t. All right. So let's go ahead and plug this into our calculator. So we have ln of 0.045 divided by 0.45, giving us negative 0.2303 is equal to negative 0.00812 minutes to -1 times t. So let's divide by that, 0.00812 divided by 0.00812 minutes to -1. So I end up getting time is equal to 283.6. So 280.6 minutes equals the time. All right. And just in case you got a little bit confused by units, if you have a certain number to a negative power, and if it's on the denominator side, then you could flip it over to the top to make it the opposite power. So it's going to be minutes to the 1, which is just minutes. And the same is the opposite is true as well. Let's say we had minutes to the -1 up here. If we flipped it to the bottom, it will just be minutes to the 1, except it will be on the denominator. Just in case you didn't know that already. So as you can see right here, or if you've been doing it on your own, the answer to our problem here is 283.6 minutes. And if you're doing the same problem set as I am, if it's letter E, and they rounded it here to 284 minutes. And that will be our answer. And I hope you found everything helpful. I hope you understand everything. And good luck on any future instances where you're going to be doing similar problems to this. And thanks for watching. I hope you enjoyed.